Okay, so today we're going to start by looking at something new, which is circles in trig. So the first thing we need to do now is start looking at some new vocabulary. So our first new term is going to be something called central angles. And central angles are just an angle that's formed by two radii, which is just the plural of radius, so just two radii of a circle, where the common endpoint is the center of the circle. Now the other two endpoints create something that we call an arc on the circle. So the other two endpoints an arc. We're going to go over that right now. So let's go ahead and look at an example. So we have our circle, and we have a problem where P is the center of the circle. We know that this radius right here is A. We're going to call this radius B. We want to find our y degrees here. If we know that this space here, this arc, the major arc AB, which is the longer arc here going all the way around, we know that this measures 260 degrees. But now we need to know, we want to find arc AB or X here, right? So what we can do is that we know that 360 degrees is the full angle measure of a circle. We can subtract our 260 that we know, and that's going to give us 100 degrees. We know that arc, now this is how we're going to write arc AB is equal to 100 degrees. Now, when we work with central angles, we know that whatever our arc is, so X or arc AB is 100 degrees, we know that that's going to be the exact same thing as our central angle. So we know that arc AB is equal to Y, so then we know that Y is equal to 100 degrees. Now we're going to move on to something called inscribed angles. And an inscribed angle is just an angle that is formed by two chords that have a common endpoint. We call this the vertex. Endpoint, the vertex. And this can be placed on anywhere on the circle. So it doesn't have to be the center of the circle like it does for central angles. So let's go ahead and look at an example. So we have our circle, and we have a point right here, which we're going to call A. We have a chord here for point B, and a chord here for point C. So now, and we have our center of the circle right here, right? If it's given that arc AB measures 180 degrees and arc AC measures 140 degrees, how can we find angle X in this case? So we need to really think about, again, what we're given, right? So we know that a circle is equal to 360 degrees. We can take away the 180 and the 140. So 360 minus 180 is equal to 180. 180 minus 140 is going to give you 40. So we now know that arc BC is equal to 40 degrees. But we want to find angle X. So, but in this case, inscribed angles are different than central angles. In central angles, the arc and the angle are the same thing. In inscribed angles, the inscribed angle is 1/2 of the arc. So we know that angle X is equal to 1/2 of 40. So we know that X is going to be equal to 20 degrees. So we know that BC is 40 and angle X is 20 degrees. And now the next term that we're going to be looking at is something called a tangent line. You may have heard of this one before. A tangent line is just a line that touches the circle in exactly one point. So what I mean by this is we have our circle with our center C, and what a tangent line is just, it's going to look something like this. Or that's more of a secant. Let's see if I can get it closer. Yep, so that would just be our one point right here where our line touches the circle. And we can call this point Y, right? This will be Q, this will be R. So what we can do now is set up our problem where our diameter here, which is just from one point to the other, that's equal, where these two are equal, right? So just a radius and a radius put together will give you the length of the diameter for this. And we know that this is point X, and we have another point drawn from our tangent line to the end of the circle, and this is point P. So one interesting thing now is that we know that angle XYP is an inscribed angle of this circle, right? Because we have one point on the edge of the circle that goes to two other sides, right? And something that's interesting now when we work with tangent lines or segments is that whatever angle here, so the tangent line will always be perpendicular to the radius or diameter that we're looking at here, right? So that means that this angle right here has to be 90 degrees, right? And because it's a line, we know that this angle on this side also has to be 90 degrees. So if we know that angle, the measure of angle X, Y, P is equal to 32 degrees, how can we find the measure of angle PYR? So what we can do is, if we know that XYR, the measure of angle XYR is equal to 90 degrees, all we have to do is subtract 32 from that. So the measure of angle LPY is equal to 90 minus 32, and then we get the measure of angle LP. One second. The measure of angle LPY is going to be equal to 58 degrees. So because we know these are perpendicular, we know this right here is 32. That means that this angle has to be 58 degrees.